we want to determine the number of households in Monroe City that would favor a tax increase to fund a new baseball field. That's kind of an outdated question now, but ideally we would ask all the households in Monroe City, right, and find the proportion that would be in favor. But that's kind of what happens when you vote. You're asking everyone. Before an election, do they know 100% what's going to happen? No. What they do is they take polls. They'll ask a group of people, and they'll take that number to try to estimate the whole group, right? So they kind of have an idea. So if we can't ask everybody, we can get a point estimate from the proportion. So it basically is called p hat, and it's just finding the number that's in favor. So you ask in people, X of them agree. So you take a sample, and you're finding what percent agree with you. So to find a point estimate, we do X over N. So for example, if we had a poll conducted, 1,745 registered voters nationwide were asked whether they approved of the way George W. Bush was handling the economy. 349 responded yes. Obtain a point estimate for the proportion who approve. So we want point estimate is p hat, X over N. We are measuring those who approved. So how many approved? 349 out of how many total? And so our point estimate is 0.2. 20% agreed with him. All right. Some key things here. Kind of like we saw with the sample means, when N increases, the shape becomes more normal. It's not as cut and dry as with the means. So with the means, we just said if we have more than 30, we can assume it's normal. That's not quite as clear here, and we'll talk about what the requirement is in a second. The mean is the population proportion. And the standard deviation, just like yesterday, it's going to get smaller when N gets bigger. So the bigger our sample, the less error we are going to have in it. So the things for our sampling distribution of p hat. This is kind of the important slide with the stuff we need. The shape becomes normal if N times p times 1 minus p is greater than or equal to 10. The mean is p, and standard deviation is the square root of p times 1 minus p over n. Really, the only thing that you need to memorize from the last 2 days is the criteria to be normal. The mean and standard deviation are given on our formula sheet. What we have to remember is if we're talking about x bar, N has to be bigger than 30 to be normal. If we're talking about the p hats, N times p times 1 minus p has to be greater than 10 in order to be normal. So that's our criteria that we'll be checking today. So then if it's normal, we can find the mean and standard deviation, get z-scores, and do all the same probabilities as before. The requirements, this also kind of assumes that everything is independent. You know, one person's answer doesn't change another person's answer. In general, we will assume independence if our sample is less than 5% of the whole population. I'm not going to use that a ton right now. We'll talk about it on everyone and just kind of make a note of it. A lot of times we can't actually verify that, but if we're talking about the entire nation, you know, a sample of 1,000 would be less than 5% of everybody. Most of them, it's going to be fairly clear cut. Even if it doesn't meet the requirements for normal, the mean and standard deviation formulas work. So those are not going to change if it's not normal. All right, so let's look at this example. According to a poll, 42% of registered voters believe the president should be impeached. Suppose that we obtain a simple random sample of 50 voters and determine which voters believe the president should be impeached. Describe the sampling distribution of the sample proportion. So when I ask you to describe it, I'm asking for the criteria, the mean, and the standard deviation. And I think we did one yesterday that asked for describe the sampling distribution and the sample mean. So anytime I ask you to describe it, it's just check your criteria, find your mean and your standard deviation. The criteria. We need it to be independent. So our sample has to be less than 5% of the total population. Do I know my entire population? No, so I can't really mathematically check it here, but would 50 voters be less than 5% of everybody? Yeah. So we're just going to say, yep, we thought about that, that's true. The second criteria is N times P times 1 minus P. Has to be greater than or equal to 10. This one we can check. What's my N here? How many people? What is the P, the proportion we're looking at? So 0.42, 1 minus 0.42. That gives me 12.18. So is that bigger than 10? Yep. So we met our two criteria. That means we know they're independent and it's big enough to be normal. Our mean. We can look back at that slide. We can look at the formula sheet. It tells us the mean for our sampling distribution is just P, our proportion. What was our proportion? Mm-hmm. And standard deviation. It said the square root of P, 0.42, times 1 minus P over N, which was 50. So our standard deviation is 0.0698. Any questions there? Let's do one where we have to calculate some probabilities. So according to the Center for Disease Control and Prevention, 18.8% of school-aged children ages 6 to 11 years were overweight in 2004. Part A. In a random sample of 90 school-aged children aged 6 to 11, what's the probability that at least 19 are overweight? We have a lot of numbers here. So what we need to make sure we can pick out is the N and the P. Okay, the P is from the population. What is the, so you can think P is percent, it's a proportion or a percent. What's the percent that's dealing with the entire population? Okay, so this is my P. And then N is the number we're looking at, so that is my 90. Okay, first thing we have to do is actually make sure that we can use the stuff. So we need to check our criteria. The first one, most of the time we're not really going to be able to check. Our sample has to be less than 5% of the total population. I don't know the population of all school-age children, but do you think 90 is less than 5%? Yeah. The second one we can check. We need to see if N times P times 1 minus P is greater than 10. So my N is 90. My P, change it to decimal form, so 0.188. 1 minus 0.188. So that does turn out to be bigger than 10. So these criteria are met, which tells me it's normal. That means we can do the z-score and our normal probabilities. So now let's figure out what it's actually asking us to find. What's the probability? So we're finding the probability that at least 19% are overweight. Okay, this is talking about a percent, so that's like our P hat. At least means that many or more. So we're finding the probability that a P hat or a proportion is greater than or equal to 0.19. What do we have to do to that though? We have to get the z. In order to get the z, we need the mean and standard deviation for P hat. What is the mean for P hat? The P, what did we say our P value was? 0.188. Okay, standard deviation for P hat is the square root of P times 1 minus P over N, which we said was 90. So now we get the z. So z is our value, which was 0.19, minus the mean, 0.188, divided by the standard deviation. And I think I did give you guys like a blank slide after that one, didn't I? So you have a little more work. So. So plug that in, we get our z, we get 0.05. So we always take that, our table has 2 decimal places. How do we do greater than? So then we go to our table and look up the 0.05. And we get 0.5199. So 1 minus 0.5199 gives us 0.4801. We have 0.0. Alright. Part B says, suppose a random sample of 90 school-aged children, ages 6 to 11, results in 24 overweight children. What might we conclude? Okay, if we are using p's, then when we're finding probability, we have to have a p-hat. We have to have a proportion or a percent. I gave you the number of overweight children. How would I get my p-hat from that? Yeah, 24 divided by 90. Yeah, we divided by 90. So we have to first find the p-hat here because I didn't give you the percent. Doesn't work out beautifully. We'll keep a few decimal places for now. 0.2667. Okay, so remember, our mean is 0.188. We have to decide, we're trying to figure out if this is unusual or not. Would it help me to find the probability of being less than this amount? Because my mean is less than that, so don't I expect most children to be below that amount? So if I really want to figure out if this is an unusual probability, I need to find the probability that we are greater than this. Does everyone understand why I picked greater than there? Because my mean is smaller. So if you think about like your normal distribution, it's centered at 0.188. We're looking at 0.267. So we have to find probability one way or the other. We expect everybody to be less, so we're going to see if it's unusual to be more. So now we need a z. We can use the mean and standard deviation we found up before, so our value minus the mean divided by the standard deviation. So we get the probability that z is greater than 1.91. To do greater than, we do 1 minus. Look up 1.91. So the question was, what would we conclude? Is this common? No, this is unusual. So which means the sample is likely different from the population. It's it's not impossible for this to happen, but if my sample is truly matching my population, it would be extremely unlikely. So there's some other thing going on here. Maybe my sample had similar, I don't know, lots of different things. Maybe a different community. They have different eating habits there. Maybe they're all the same ethnicity and there's some difference there. Maybe there's a lot of relatives in this area and there's some genetic thing. For some reason, this group is different than the population. We don't know what that reason is. We just know it would be very unusual for this to happen. So for some reason, our sample doesn't quite match the population. All right. Any questions there? Let's do another one. According to the National Center for Health Statistics, 15% of all Americans have hearing trouble. When I see that 15%, what is that telling me? That's our P. Anytime we see percents, we're talking about that proportion there. Come in. Thank you. And a random sample of 120 Americans. What's the 120? What's the probability that at most 12% have hearing trouble? So what do I need to do before anything else? Criteria. Okay, it's not like yesterday's problems where I can just look and it tells me it's normal or it tells me my sample's bigger than 30. We have to verify. First, the sample has to be less than 5% of the total population. I don't know the population of all Americans, but would 120 be less than 5%? Yeah. I mean, then 5% of all Americans. Yeah. So, most of these, the 5% one, we probably aren't going to be able to check, but you're writing it down to tell me you thought about it. The second one, we need to check N times P times 1 minus P has to be greater than or equal to 10. So my N is 120, P 0.15, 1 minus 0.15. So that criteria is met. So that means we can assume this is normal now. And we can use the Z's and the probabilities from the table. So in part A, we want the probability that at most 12%. So if I'm talking about percent, my variable is p hat. At most means what? 12% would be 0.12. All right, where do we go from here? Z-score. To get the Z, we need the mean and standard deviation for p hat. What's the mean for p hat? 0.15, the original p for the population. And to get our standard deviation, we do the square root of p times 1 minus p over n. My n was 120. That's 0.0326. So now we can get Z. Z is our value minus the mean divided by standard deviation. frequency of negative 0.92. Less than is what our table tells us, so we just have to look this up. We get 0.1788. Part B. Suppose that a random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. What might you conclude? So what do I need to do here? We have to get our p-hat. How do you get p-hat? So p-hat is 0.2167. Is that higher or lower than we would expect? It's more than the mean, correct? So if we think about, in our normal distribution, this one is centered at 0.15. We're talking about 0.2167. So if I want to figure out if this is unusual, what do I need to find the probability of? So turn it into a z. R value minus the mean divided by our standard deviation. Probability is greater than 2.05. Greater than is 1 minus 0.9798. So what do we conclude? It would be very unlikely. So what about this group caused them to have more hearing loss? They have headphones. So it said, what might you conclude? That means there's not just one right answer, but we could conclude that headphones cause more hearing loss. You could have also just said, we had a bad sample, or maybe the real mean was higher than 0.15. There's a lot of different things. It says, what might you conclude? So something that would be reasonable to assume. Do we need more problems like this? So you guys have the chapter 8 packet. So you've got now and probably, in class time tomorrow. We might do a few review problems tomorrow if we need to. If we're having a little trouble and need a refresher, we definitely will. So you guys have the rest of the hour to work.